Hello, this is Rick Gupta with SimStation. I'm going to show a quick video on how to create paint plumes. And when I say paint plumes, it can either be for depositing paint or it can be a model of a sander that's removing paint. But in both cases, they give an idea of how much paint is applied or removed. Overall, there's two different shapes. We can either use a cone shape or we can use a bell shape, and then we can put in different parameters. And then there's a paint deposition function, and we have several to choose from. One is a measured, where you can take a 2D, you spray a piece of paper or whatever, and then you measure the thickness on a 2D grid. You can enter those, or you can you spray it along as it's moving, and then you just take a slice through it, and you figure out the profile, and you can use that. You can use a bi-Gaussian mathematical model of it, Gaussian, sine, cosine. Then we'll get to this later. Um, by Gaussian, a lot of times you have a painting gun and it has a little plug in the center to distribute the paint more, so it doesn't come out sort of in right in front. And then you have different values for the air pressure, the mist pressure, dry weight, flow rate. You can kind of simulate after you paint it. Uh, then it's going to dry at half the thickness, or you can set that parameter. So what we're doing now is we're integrating the plume. So this red line you see is this line that's randomly going through. I don't think it's too random. It's pretty systematic. Going through the plume, and it's measuring um, how much paint is being deposited, integrating all the paint from the different inside of the paint plume, and figuring out how much paint is deposited on that vertex. Because that's how we actually paint. We take this plume and we move it over a surface, and at each vertex, we say how long did it go through the plume and at what path, and then we can figure out how much paint was deposited or how much paint was removed. Then what we can do is just kind of an example. We can spray this plume on a surface, stationary surface, right here. So there you get an idea of, by Gaussian, you're going to get the heaviest flow right here and kind of light in the middle, light at the edges. And then we also have a moving test where you just kind of move it along. And so notice it only works with the plumes or the points that are starting inside or starting outside and then go through complete plume. Points that are on the inside of the plume don't get counted. If you want to do a full integration, then we can take that into account also. This is just a lot faster. So we can see that this gives kind of this view. This is let me just do some things here. This is the resolution at which we're checking. So each one of these vertices is then the plume passes over it, and we calculate how much paint is put there. And we color it with a different color depending on thickness. And then we can either flat shade it or smooth. We try to like smooth it together like that. All right, so you can get an idea of how much paint is put on there. So another nice thing we can do here is we will use, instead of a bi-Gaussian, we're going to use this sanding PDF. And this is incorrect. This should go down to the center. So a slice through there, you're going to have heavy removal on the side, and it's going to linearly go down. And that's just a guess at whatever the sanding PDF is. But basically what we're thinking is, because if this was a sander instead, the outer parts would be rotating faster and they'd be more aggressive on the paint removal. So when we integrate it, we're going to get, we'll see that we'll get more removal on the outside, less in the center, and then get more on the outside. And we could also put in a model where it degrades over time so that it becomes less effective as how many feet it's already sanded, then it becomes less removal. So it's all kind of mathematical. We can put that in. If we had some data on that, we can make it less effective over time as if it were wearing out. The nice thing about this model is that You can change the shape of it. We can make it really small. You could have multi-pass, and then those add up. So you could say like the first time through it took this much off, the second time it took this much. So we can make it as complex as we need to get accurate results. So here's the kind of the what we'd expect, kind of heavy removal on the outside, lighter on the inside. I don't know if this is a little bit more accurate, I think, if this without smooth shading on it. And if we do the moving test, you can kind of see that yeah, more on there'd be a lot more wear here. There's less. This standing disc only comes through here a short amount of time, but it goes through here a lot of time. We can actually change this up and we can get an idea. So probably most time is spent in this rotary cycle is spent in these two areas. So you get that's kind of the pattern you'd expect to see for most aggressive removal here. Yeah, it's pretty heavy. Well, it's kind of it's fairly sloped here. You get an idea of how it bunches up. Okay, let me know if you have any questions. Thanks.